February 20th, 1943. The sun had barely broken over the horizon in North Africa, casting long shadows across the barren terrain north of Kasserine Pass, Tunisia. German tank commanders, veterans of campaigns across Poland, France, and the endless steppes of Russia, peered through their periscopes at a sight that would haunt their after-action reports for weeks to come. Through the dust and smoke of the North African battlefield, 5 American Sherman tanks, separated by broken terrain with no line of sight between them, converged on German positions with a timing that seemed almost supernatural. No flags waved between the vehicles, no flares arced through the morning sky. No dispatch riders raced on motorcycles between the scattered formations, yet these 5 tanks moved as a single organism, each crew covering blind spots the others couldn't see, each commander knowing exactly where his comrades were positioned, as if guided by some invisible hand. This was no miracle of battlefield intuition. This was technology, a revolution in military communications that would reshape the nature of armored warfare forever. Welcome to this World War II history documentary, where we uncover one of the most decisive yet least celebrated technological advantages of the Second World War, the story of how American Sherman tanks didn't win through superior armor or devastating firepower, but through something far more powerful, the ability to communicate. This is a war documentary about the electromagnetic spectrum, about invisible waves that proved more lethal than any artillery barrage, and about how the United States military achieved total information dominance before that term even existed. Before we dive deeper into this untold story of War II, if you're fascinated by military history and the hidden technological battles that shaped our world, take a moment to hit that subscribe button and ring the notification bell. And I'd love to know where you're watching from today. Drop your city or country in the comments below. It helps build our community of history enthusiasts from around the globe. Now, let's return to that dusty battlefield in Tunisia and understand what those German tank commanders were really witnessing. Inside the German Panzer, Mark IV tanks equipped with the standard Funkgerät 5 radios, commanders struggled to hear their own company leaders through waves of static that overwhelmed their amplitude modulation systems. The 10-watt German transmitters, considered state-of-the-art by 1930s standards, couldn't penetrate more than a few hundred meters when the tanks were moving across rough terrain. The engine noise, the grinding of tracks, the electrical interference from every spark plug firing, all of it combined to create a wall of static that drowned out human voices. And that wasn't even the worst part. Most German tanks in a standard platoon carried only receivers, unable to transmit at all. They could hear orders, assuming the static wasn't too severe, but they couldn't respond, couldn't report what they saw, couldn't call for help when they encountered the enemy. They fought partially blind and entirely mute, dependent on visual signals that became useless the moment dust or smoke obscured the battlefield. The Americans, meanwhile, were operating with technology the Germans didn't even know existed. Every single Sherman tank, from the command vehicles down to the lowest-ranking crew in the platoon, carried frequency modulation radios. Crystal-controlled precision ensured they stayed on the exact same frequency. 25 watts of transmission power, 2.5 times what the Germans could muster, pushed their signals through interference that would have silenced less sophisticated equipment. The clarity was astonishing. Commanders could hear their crews as clearly as if they were standing next to each other, even with the engine roaring and the 75mm gun firing. They could coordinate complex maneuvers across kilometers of broken terrain, maintain contact through artillery barrages that would have rendered German radios useless, and adapt their tactics in real time based on information flowing constantly between every vehicle in the formation. 8,000 miles from that Tunisian battlefield, in the sprawling factory complexes of Detroit and Chicago, the most decisive technological advantage of World War II was being mass-produced at a scale that would have seemed impossible just years earlier. This wasn't about armor thickness, though American engineers worked tirelessly to improve the Sherman's protection. This wasn't about gun caliber, though the 75mm gun would eventually be upgraded to handle the German threat. This was about the invisible electromagnetic waves that connected every American tank crew in ways the Wehrmacht never imagined possible, And the story of how that advantage came to be is a tale of American industrial genius, scientific innovation, and military foresight that began years before the first shots were fired in Tunisia. To understand the magnitude of what the United States achieved, we need to step back to the summer of 1941, when the war in Europe was already 2 years old, and America stood on the precipice of entry into a global conflict. July 22, 1941. While German forces were advancing deep into the Soviet Union, executing the largest invasion in human history, American military planners were making a decision that would prove more consequential than almost any tactical choice made during the war. The United States Army Signal Corps standardized 3 radio sets for all medium tanks: the SCR-508, the SCR-528, and the SCR-538. These seemingly bureaucratic designations represented a revolutionary commitment. Every American medium tank, every single one that would roll off the assembly lines in the coming years, would carry sophisticated radio equipment as standard issue, not as a luxury reserved for command vehicles. At that moment, American doctrine diverged fundamentally from both German and Soviet approaches to armored warfare. The Germans, despite being pioneers in the use of radio-equipped tanks, had never achieved universal deployment. The Soviets, producing tanks at an extraordinary rate to replace catastrophic losses, rarely equipped their T-34s with any radio at all. American planners looked at the emerging nature of mechanized warfare and reached a different conclusion. If armor was to fight as coordinated formations rather than as collections of individual vehicles, then every tank needed the ability to communicate. It was a logistical and industrial challenge of staggering proportions, but American industry was uniquely positioned to meet it. The engineering team that made this possible worked at the Galvin Manufacturing Company in Chicago, a firm that would later become famous under a different name, Motorola. Before the war, Galvin had been a moderately successful manufacturer of car radios, the kind you'd find in a Ford or Chevrolet. The company had expertise in making reliable electronics for harsh environments, radios that had to function despite engine vibration, electrical interference, and the rough treatment of daily use. When the Army Signal Corps approached them about adapting frequency modulation technology for military vehicles, Galvin's engineers recognized both the challenge and the opportunity. The man who conceived the application of FM technology in military vehicles was Daniel E. Noble, a brilliant engineer who understood that Edwin Armstrong's frequency modulation patents, which had revolutionized civilian radio broadcasting, could solve the military's communication problems. Noble's insight was that FM's resistance to interference, its ability to deliver clear audio even in electrically noisy environments, made it perfect for the chaos of a battlefield. But recognizing the potential was one thing. Making it work in the confined, hot, vibrating hell of a tank's interior was something else entirely. That's where Henryk Magnuski came in, the principal RF engineer who solved the technical challenges of installing sophisticated electronics in an environment that seemed designed to destroy them. Temperature extremes from desert heat to Russian winter, constant vibration from the engine and the movement across rough terrain, electrical interference from every system in the tank. Magnuski and his team had to create equipment that would function reliably under conditions that would kill most civilian electronics within hours. The result of their work weighed 181 pounds and transformed every Sherman tank into a node in what was, without exaggeration, the world's first battlefield network. The BC-604 transmitter, the heart of the system, generated 25 watts of power across a frequency range of 20.0 to 27.9 megahertz. It provided 10 preset channels with crystal-controlled stability, meaning crews could switch between frequencies without the constant retuning that plagued German equipment. The dual BC-603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove decisive in combat. A commander could listen to his platoon net on one receiver and the company command net on the other, maintaining awareness of both his immediate tactical situation and the broader operational picture. This wasn't just an incremental improvement over existing technology. This was a generational leap, And the real revolution lay not in the power output or the frequency range, but in the modulation itself, in the fundamental physics of how these radios transmitted information through the electromagnetic spectrum. To understand why frequency modulation represented such a dramatic advantage, we need to briefly examine the difference between FM and the amplitude modulation systems that everyone else was using. And this gets to the heart of why American tanks could coordinate while German tanks struggled to communicate. Amplitude modulation, the technology behind German radio systems and most civilian broadcasts of the era, works by varying the strength of a radio wave to encode information. When you speak into an AM microphone, your voice causes the amplitude, the height of the radio wave to fluctuate. It's simple, it's reliable, and it had been the standard for decades, but it has a fatal flaw in military applications. Any electrical noise in the environment affects the amplitude of the radio wave, and a receiver can't distinguish between legitimate signal variations and interference. Every spark plug in the tank's engine generates a tiny electromagnetic pulse. Every electric motor, every bit of metal-on-metal friction that creates static electricity, every nearby radio transmitter, all of it shows up as noise in an AM receiver. Now imagine trying to use AM radio in a tank. The engine is running constantly, generating interference. The tracks are grinding against the ground, creating more interference. You're moving across a battlefield where other tanks, artillery, and enemy radio systems are all adding to the electromagnetic chaos. The result is that AM systems, even well-designed ones like the German WWII, could barely function when tanks were in motion. Static overwhelmed the signal. Voices became unintelligible. Communication broke down precisely when it was most needed, in the heat of combat. Frequency modulation, pioneered by Edwin Armstrong and licensed to the military by the late 1930s, takes a completely different approach. Instead of varying the amplitude of the radio wave, FM varies its frequency, the number of times per second the wave oscillates. When you speak into an FM microphone, your voice causes tiny shifts in the frequency of the transmission. The brilliance of this approach is that interference primarily affects amplitude, not frequency. All that electrical noise from the tank's engine and tracks still exists, but an FM receiver can filter it out because it's looking at frequency variations, not amplitude variations. The result was clarity that seemed almost magical to anyone who had struggled with AM systems. American tank crews could communicate clearly even during artillery barrages, could maintain contact while moving at full speed across rough terrain, could coordinate complex maneuvers in conditions where German radios produced nothing but static. This wasn't a small advantage. This was the difference between fighting as a coordinated unit and fighting as isolated individuals, and the implications would become clear when American armor first entered combat in the autumn of 1942. November 8, 1942 marked America's entry into the ground war in Europe with Operation Torch, the invasion of North Africa. The 2nd Armored Division's tanks rolled off landing craft near Safi and Fedala in Morocco, each one equipped with the SCR-508 radio that would soon demonstrate its superiority over German communications in the most brutal classroom imaginable: combat. The Afrika Korps, commanded by Field Marshal Erwin Rommel and widely considered the Wehrmacht's most experienced and effective armored force, operated under communication limitations that would have shocked American planners if they had fully understood them. A standard German tank platoon consisted of 5 vehicles, but only 1 or 2 of those vehicles carried full Funkgerät 5 transceivers capable of both transmitting and receiving. The remaining tanks were equipped with Funkgerät 2 receivers only. They could hear orders transmitted by the platoon leader, assuming the signal was strong enough and the static wasn't overwhelming, but they couldn't respond. They couldn't report enemy positions. They couldn't call for help if they were damaged or surrounded. They couldn't warn their comrades of threats they had spotted. They fought mute, dependent entirely on their ability to maintain visual contact with the command vehicle and interpret its signals. This created a rigid hierarchy that was both a strength and a critical vulnerability. When the system worked, when visibility was good and the command tank remained functional, German platoons could execute complex maneuvers with the precision that had made the Wehrmacht famous. Subordinate tanks watched their leader and followed his actions, moving when he moved, firing when he fired, maintaining formation through training and discipline rather than through constant communication. But when command tanks were destroyed, and they were easy to identify by their multiple antennas marking them as high-value targets, entire platoons lost coordination. Without someone to transmit orders, the receiver-only tanks had no way to coordinate with each other. They became, in effect, individual vehicles fighting separate battles within the same engagement. This vulnerability would prove catastrophic against American forces where every tank could assume command functions, where the destruction of one vehicle barely degraded the unit's ability to coordinate and adapt. The contrast couldn't have been starker, and it was about to be demonstrated in the harsh crucible of North African combat, in a series of engagements that would stun Wehrmacht observers and reshape American confidence in their equipment. The Battle of Kasserine Pass, February 14th to 24th, 1943, was the first major engagement between American and German armored forces, and it's often remembered as an American defeat, a harsh lesson in the realities of combat against veteran Wehrmacht troops. Tactically, it was indeed a German victory. Rommel's forces drove the inexperienced American troops back, inflicted significant casualties, and exposed weaknesses in American doctrine and leadership. But the battle also revealed capabilities that stunned German observers, capabilities that wouldn't fully be understood until much later. During the confused fighting across 50 miles of Tunisian desert and mountains, scattered elements of the United States 1st Armored Division maintained coordination that should have been impossible. Tank crews who had never met, who belonged to different companies and sometimes different battalions, found themselves coordinating attacks through crystal-clear FM communications. They warned each other of threats, called for artillery support, and adapted their movements based on information flowing constantly across the radio network. When German counterattacks threatened to overwhelm isolated American positions, tanks from other sectors received word within minutes and moved to provide support. The response times were unprecedented for armored warfare at that scale. German signals intelligence units, listening to American transmissions, noted the exceptional clarity and the volume of traffic. The 10th Panzer Division's intelligence section filed reports that expressed genuine puzzlement. American units were maintaining communication at ranges where German radios produced only static. More disturbing was the realization that every American tank appeared capable of full transmission, not just command vehicles. The implications took time to sink in. If every enemy tank could communicate, then destroying command vehicles didn't degrade their coordination. If they could maintain contact across vast distances through interference that silenced German equipment, then they possessed a significant technological advantage. But what was the source of this advantage? The German reports speculated about training, about communication discipline, about the possibility that Americans were using more powerful transmitters. They didn't yet understand that the fundamental technology was different, that frequency modulation represented a generational leap beyond what German equipment could achieve. The reports made their way up the chain of command where they were noted, filed and largely forgotten in the press of more immediate concerns. The Africa Corps was fighting for survival, trapped between British forces advancing from the east and American forces, inexperienced but learning rapidly, pressing from the west. Technical assessments of enemy radio equipment seemed less urgent than the daily struggle to maintain defensive lines and preserve combat power for the inevitable retreat. The German Funkgerät. Fünf radios operating on amplitude modulation in the 27.0 to 33.3 MHz range suffered from fundamental limitations that no amount of tactical skill could overcome. The 10-watt transmitter, perfectly adequate for stationary use or in ideal conditions, struggled to reach 2 to 3 kilometers when vehicles were moving. In combat, with engines at full power and tracks churning across rough terrain, that range often dropped to mere hundreds of meters. Every spark plug firing generated a pulse of electromagnetic interference. Every electrical motor in the tank added its contribution to the noise. Every track link grinding against another created static electricity that the AM system couldn't filter. The result was that German tank commanders often couldn't hear transmissions from their own company leaders, let alone maintain contact with higher headquarters or coordinate with adjacent units. And this was the state-of-the-art equipment, the Funkgerät 5, that equipped command tanks and was considered a valuable resource. The majority of German tanks carried only the Funkgerät WWII receiver, which provided no ability to transmit at all. The contrast with American capabilities was profound, and it would become even more apparent as the war moved to new theaters. September 1943 brought American armor to Italy, a terrain that should have negated radio advantages. Mountains block radio signals, valleys create multipath interference where signals bounce off terrain and arrive at the receiver multiple times at slightly different moments, causing distortion. The Germans expected their communication problems to be matched by American difficulties. Instead, they discovered that FM technology proved even more valuable in conditions that rendered German AM radios completely useless. The SCR 508's frequency modulation handled the multipath interference of mountain valleys far better than amplitude modulation. While German commanders found their radios producing nothing but incomprehensible static in mountainous terrain, American tanks coordinated movements through areas where visual signals were impossible, and radio communication should have been equally impractical. During the grinding advance toward Cassino, where every ridgeline became a defensive position and every valley a potential killing ground, American armored units demonstrated capabilities that defied German understanding of what was possible with radio communications. Tank platoons separated by ridgelines, with no possibility of visual contact, coordinated attacks with precision that German doctrine insisted required line of sight between vehicles. The 1st Armored Division's after-action reports, mundane documents filed by tired officers trying to capture lessons learned, described routine coordination at distances where German radios produced only static. These reports, studied decades later by military historians, reveal the magnitude of American advantage in prose that understates its significance precisely because it had become routine. Commanders wrote about calling for artillery support from tanks 5 kilometers away, about coordinating movements with units they couldn't see, about maintaining unit cohesion across terrain that should have fragmented their formations, and they wrote about these achievements as if they were unremarkable, as if this was simply how armored warfare worked. For the Germans on the receiving end, these capabilities seemed almost supernatural, and they had no effective counter because they didn't fully understand what they were facing. The year 1944 would bring the technological advantage of American tank radios to its fullest expression, across multiple theaters and in battles that would help decide the war. June 6th, D-Day, the largest amphibious invasion in history, saw Sherman tanks rolling off landing craft at Normandy, with their SCR 508 radios maintaining contact with naval fire support ships. This coordination, impossible with German technology, which couldn't bridge the frequency gap between different service branches, allowed American tanks to call for devastating naval gunfire within minutes of identifying targets. When German counterattacks threatened to drive the invasion back into the sea, American tank crews could speak directly to ships offshore, could adjust fire in real time, could bring the massive guns of battleships and cruisers to bear on Wehrmacht positions with a speed that shocked the defenders. But the Normandy hedgerow fighting, brutal combat through the bocage where every field became a potential ambush site, revealed a critical gap in the American communication system. Tank radios and infantry radios operated on different frequencies. The SCR 508 in the tanks used 20.0 to 27.9 MHz, while the infantry's SCR 300 backpack radio operated on 40.0 to 48.0 MHz. They couldn't talk to each other, and this communication gap proved deadly. In the hedgerows where German infantry with Panzerfaust anti-tank weapons could approach to within meters of American tanks, while nearby American infantry had no way to warn them, casualties mounted. Tank crews, buttoned up inside their vehicles with limited visibility, depended on infantry to provide security and warn of threats. Infantry needed tanks to suppress enemy positions and provide mobile firepower. But they couldn't communicate directly, and the gap between their radio frequencies created a coordination problem that cost lives. American ingenuity solved the problem within weeks, not through some sophisticated technical modification, but through simple battlefield improvisation that would become standard practice. Tank crews mounted EE-8 field telephones in ammunition boxes welded to the tank exteriors, wired directly to the internal communication system. Infantry could now pick up the phone, press the button, and speak directly to the tank commander inside. By the time of Operation Cobra in late July, this simple modification had revolutionized tank infantry cooperation. Infantry could warn tanks of threats they couldn't see. Tanks could inform infantry about enemy positions and request them to mark targets. The coordination that had been missing in the initial hedgerow fighting became seamless, and the results would be demonstrated dramatically in the breakout from Normandy. July 25th to 30th, 1944, Operation Cobra, the breakout that would begin the liberation of France and the race toward Germany. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control. Every tank commander could hear not just his immediate superior, but multiple levels of command simultaneously. The dual receivers in the SCR 508 meant that a platoon leader could monitor his 5 tanks on one frequency, while listening to company-level orders on another. Company commanders could track their platoons while staying informed of battalion-level developments. Battalion commanders could coordinate multiple companies while remaining aware of division priorities. Information flowed both up and down the chain of command with a speed that transformed the nature of command and control. When American tanks identified enemy positions, that information reached commanders who could redirect forces within minutes. When artillery support was needed, tank crews could call it in directly, eliminating the delays that plagued forces dependent on more rigid communication procedures. The German defenders from the Panzer Lehr division faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by other units miles away. Artillery strikes, coordinated through tank radios, arrived within minutes of target identification. When German forces attempted to mass for counterattacks, American units detected the concentration and called in devastating airstrikes before the attack could develop. The coordination was overwhelming, and it broke Panzer Lehr, once considered one of Germany's premier armored divisions, as a fighting force. The contrast with German capabilities during Cobra was stark and tragic. Panzer Lehr had been reduced to what American intelligence reports would describe as communication poverty. Most tanks operated without radios at all, depending on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning radios suffered from the interference and limited range that had plagued German equipment throughout the war. Unable to coordinate effectively, unable to concentrate forces without being detected, unable to adapt to rapidly changing situations, Panzer Lehr was destroyed piecemeal by an enemy that seemed to know where every German tank was positioned and could mass superior force at any point on the battlefield within minutes. The irony of this situation was profound and bitter for those German officers who understood what was happening. Germany had pioneered radio use in armored warfare. Heinz Guderian, the architect of Blitzkrieg and one of the most innovative military thinkers of the 20th century, had insisted on radio equipment in tanks since the 1920s. His book, Achtung Panzer, published in 1937 before the war began, emphasized communication as essential to armored operations. Guderian had developed the radio communication systems that enabled tank officers to coordinate the sweeping advances through Poland and France, the advances that had made the German military seem invincible. He understood that the speed of armored operations, the ability to penetrate deep into enemy territory and exploit breakthroughs before the enemy could react, required reliable communication that was faster than motorcycle messengers or telephone lines. Yet by 1943, German tank production couldn't provide the radios that Guderian's own doctrine demanded. The statistics reveal a crisis that German leadership never adequately addressed. In 1943, Germany manufactured approximately 5,700 medium and heavy tanks, but fewer than 2,000 Funkgerät 5 transceivers. The math was brutal. Even if every transceiver went to tank units, which they didn't because assault guns and other vehicles also needed radios, most German tanks rolled off the production lines without any ability to communicate. The reasons for this failure were complex, rooted in German industrial organization, strategic priorities, and perhaps a failure to fully understand how warfare was evolving. Radio production required specialized components, skilled labor, and manufacturing capacity that was also needed for other priorities. Germany was fighting a multi-front war while enduring strategic bombing that disrupted production and diverted resources to air defense. Quality control for sophisticated electronics was difficult to maintain as the war dragged on, and skilled workers were increasingly scarce. But beyond these practical constraints, there seems to have been a failure of imagination, an inability to recognize that universal radio deployment wasn't a luxury but a necessity. German doctrine still envisioned tank platoons operating through visual signals and hierarchical command, a model that had worked in the early war years when German forces faced enemies with even worse communication systems. The possibility that an enemy might achieve universal radio deployment, that every opposing tank might be able to communicate with sophisticated, interference-resistant equipment, doesn't seem to have been seriously considered until it was too late to respond. If German tank forces suffered from communication poverty, Soviet forces endured communication famine. The T-34, the most produced Allied tank of the war and arguably the best tank design when it entered service in 1940, typically entered combat without any radio equipment at all. Soviet doctrine, shaped by the catastrophic losses of 1941 and the desperate need to replace destroyed units, relied on flag signals and pre-battle planning. Tank commanders gave orders before the engagement began, and subordinate crews were expected to follow their leaders and execute the plan regardless of how the situation developed. The results against German forces in the early war years were catastrophic. Soviet tank units, unable to communicate or adapt, were destroyed by German forces that, despite their own communication limitations, possessed vastly superior coordination. The massive tank battles of 1941 saw thousands of Soviet tanks destroyed, often without inflicting comparable losses on German forces, not because Soviet equipment was inferior. The T-34 was in many ways better than the German tanks it faced, but because Soviet units couldn't coordinate effectively. By 1943, Lend-Lease provided some relief. American radios, including SCR-508 sets, equipped Soviet command tanks, giving at least some units the ability to coordinate. But even by war's end, only about 25% of Soviet tanks carried radios. The Red Army continued to rely heavily on pre-battle planning and visual signals, accepting the limitations this imposed because the industrial capacity to produce both tanks and radios in sufficient quantities simply didn't exist. The comparison highlighted the magnitude of American industrial achievement. While the Soviet Union struggled to equip 1/4 of their tanks with any radios, and Germany couldn't provide adequate equipment for even half their armored forces, the United States achieved 100% deployment of sophisticated FM systems in every medium tank. This wasn't just superior planning or better resource allocation, though both played a role. This was American industrial mobilization at its peak, the transformation of civilian manufacturing capacity into military production on a scale that the Axis powers couldn't match. Motorola's factory in Chicago represented this mobilization in microcosm. Before Pearl Harbor, the company manufactured car radios and related consumer electronics, employing a few thousand workers in a facility designed for commercial production. Converting to military production required complete retooling and solving unprecedented technical challenges at industrial scale. Each SCR-508 required 2,748 individual components manufactured to exacting military specifications. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability despite temperature extremes ranging from desert heat to Arctic cold. Despite vibration levels that would destroy most civilian electronics, despite the electromagnetic interference generated by every other system in the tank. Production statistics tell the story of American industrial might transforming technical achievement into battlefield advantage. 1942, 3,800 SCR 508 family radios. 1943, 11,400 units. 1944, 24,000 units. Total wartime production exceeded 50,000 tank radio sets, each one representing hundreds of man-hours of skilled labor and millions of precisely manufactured components. This production miracle ensured that all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment, an achievement no other combatant nation approached or even attempted. It represented not just industrial capacity, but a fundamental commitment to a vision of armored warfare where every vehicle was connected, where information flowed freely through the formation, where the death of one tank or 10 tanks didn't significantly degrade the unit's ability to coordinate and fight. The Germans never achieved this vision despite pioneering it. The Soviets never attempted it, settling for equipping command vehicles and accepting the limitations this imposed. Only the Americans committed to universal deployment, and only American industry possessed the capacity to make that commitment reality. The advantages of the SCR 508 extended beyond frequency modulation and transmission power. Crystal-controlled frequency stability meant that tanks could preset 10 channels before battle and switch between them instantly without retuning. German Funkgerät 5 radios used variable capacitor tuning that constantly drifted off frequency, requiring manual adjustment to maintain contact. In the chaos of combat, with the tank moving and the crew focused on survival, German radio operators struggled to keep their equipment tuned to the correct frequency. American crews simply selected one of their preset channels and began communicating immediately. The dual receiver configuration provided situational awareness that transformed command and control. A platoon leader monitoring his 5 tanks on one receiver and the company net on the other could track both his immediate tactical situation and broader developments simultaneously. He heard his tanks reporting enemy contact on one ear while receiving company-level orders to shift position on the other. He could make informed decisions based on complete information, something German commanders often lacked because their single receiver radios forced them to choose between monitoring subordinates or listening to higher headquarters. The BC-606 intercom system integrated seamlessly with the radio, connecting all 5 crew members. The driver, the co-driver operating the bow machine gun, the gunner, the loader, and the commander could all communicate with each other and hear radio transmissions. Throat microphones picked up their voices even over engine noise. Noise-canceling headphones delivered clear audio even during combat. When the loader spotted enemy infantry approaching from the rear, he could alert the commander instantly. When the driver saw terrain obstacles ahead, he could warn the entire crew. The coordination within each tank mirrored the coordination between tanks, and both depended on reliable communication. Many German tanks lacked intercoms entirely, forcing crews to communicate through touch signals or by shouting over the engine noise. Critical information got lost or delayed. Crew members fought partially isolated from each other, unaware of threats their comrades had spotted, unable to coordinate effectively even within their own vehicle. The psychological impact of this isolation, of fighting blind and deaf within a steel box, contributed to the stress and exhaustion that degraded German combat effectiveness. Power management provided another American advantage that seems minor until you consider its implications. The SCR 508 operated on either 12 or 24 volts, automatically adjusting to the available power supply. The dynamo motor ensured stable, filtered power that eliminated electrical interference. The system could run for hours without draining the tank's batteries, allowing crews to maintain communication even when the engine was shut down. German radios, powered directly from vehicle electrical systems, picked up every spark as static and drained batteries quickly, often leaving crews without communication after extended periods of radio use. In defensive positions where tanks needed to remain hidden with engines off, American crews could still coordinate through radio, while German crews had to choose between preserving battery power and maintaining communication. The tactical advantages of universal radio deployment transformed American armored doctrine in ways that German commanders found baffling. The combat command structure, flexible task forces organized for specific missions rather than rigid divisional organizations, depended entirely on reliable communications. American commanders could create ad hoc battle groups combining elements from different battalions, could attach tank destroyers or artillery to armor formations, could integrate air support and infantry, all confident that compatible radios would allow coordination despite the units never having trained together. This flexibility was unthinkable in German doctrine, where organizational structures remained rigid, partly because communication limitations required units to train together extensively to coordinate through visual signals and prearranged plans. When American forces mixed elements from different divisions in response to battlefield developments, German intelligence officers struggled to track which units they were facing because the idea of such fluid organization seemed operationally impossible. They assumed that the presence of elements from 3 different American divisions in the same sector indicated confusion or disorganization, not realizing that this was deliberate flexibility enabled by communication superiority. The Battle of Aracourt in September 1944 demonstrated the devastating effectiveness of American radio coordination against technically superior German equipment. The 4th Armored Division faced multiple German Panzer brigades equipped with Panther tanks that possessed superior armor and firepower compared to the Sherman. On paper, the Germans should have won. The Panther's 75mm gun could penetrate Sherman armor at ranges where the Sherman's gun couldn't harm the Panther. German crews were veterans, experienced in armored combat and trained in effective tactics. But American radio coordination proved more decisive than technical specifications. Every Sherman could report enemy positions instantly. When a tank spotted Panthers, that information reached every other tank in the battalion within seconds. Tank destroyers, equipped with 90mm guns capable of penetrating Panther armor, received targeting information from tanks they couldn't see, allowing them to position for ambushes. Artillery observers in Sherman command tanks called in devastating barrages within minutes of identifying enemy concentrations. Infantry warned tanks of Panzerfaust teams that might have achieved surprise. The coordination was overwhelming. Over 3 weeks of fighting, the 4th Armored destroyed 281 German armored vehicles while losing only 41 Shermans. A 7-to-1 kill ratio that defied technical specifications and proved that superior information sharing outweighed superior armor and guns. German forces at Aracourt fought the way they had been trained, attempting to use their superior range and armor to engage American tanks at distances where return fire was ineffective. But American radio coordination allowed the Shermans to maneuver, to attack from multiple directions simultaneously, to concentrate fire on individual Panthers while the German crews struggled to coordinate without reliable communication. When a Panther destroyed one Sherman, 3 more appeared from different angles, their positions coordinated through radio reports that allowed them to attack the Panther's vulnerable side and rear armor. The Germans couldn't adapt because adaptation requires information, and their communication poverty left them fighting partially blind. Throughout the war, German intelligence failed to grasp the full significance of American communication superiority. Combat reports mentioned American coordination, noted the unusual speed of their response to developing situations, observed that they seemed unusually aware of German movements and positions, but these observations were typically attributed to training, air superiority, or simply numerical advantage. A captured intelligence assessment from September 1944 stated that American tank units demonstrated good radio discipline and coordination, and this appeared to result from extensive training and rigid communication procedures. The assessment completely missed the technological advantage. It analyzed communication as if both sides were using comparable equipment, and the difference lay in how it was employed, not in fundamental capabilities. This intelligence failure had operational consequences. German tactics never adapted to American capabilities because German commanders didn't understand what those capabilities actually were. They continued targeting supposed command tanks based on antenna configurations, not realizing that every Sherman could coordinate battlefield responses and that destroying one tank barely degraded American coordination. They planned ambushes, assuming American tanks would lose coordination when separated by terrain or broken into small groups, not understanding that radio contact maintained unit cohesion regardless of visual contact. They attempted to disrupt American communications through jamming or by targeting radio operators, not realizing that the frequency modulation technology made jamming largely ineffective and that every crew member could operate the radio if necessary. The failure to understand American radio superiority represented a broader German intelligence problem in the later war years. Strategic bombing had disrupted German intelligence gathering. The Luftwaffe's diminishing presence over battlefields meant fewer reconnaissance flights and less information about Allied capabilities. Signals intelligence units intercepted American transmissions and reported their clarity and volume, but these reports rarely reached commanders who could act on them or analysts who might recognize their significance. And perhaps most fundamentally, German military culture struggled to accept that the enemy possessed significant technological advantages. The Wehrmacht's early war successes had created a sense of technical superiority, a belief that German engineering and innovation led the world. The idea that Americans, viewed by many German officers as industrialists rather than true warriors, might have developed fundamentally superior military technology, challenged assumptions that ran deep in Wehrmacht culture. It was easier to attribute American successes to material superiority, to sheer numbers of tanks and aircraft, than to acknowledge that they had achieved a qualitative advantage in a critical dimension of warfare. March 1945 brought American forces to the Rhine River, the last major natural barrier protecting Germany itself, and their communication superiority reached its fullest expression in the rapid exploitation of a fleeting opportunity. When the 9th Armored Division's advance elements discovered the Ludendorff Bridge at Remagen, still intact on March 7th, a bridge the Germans had intended to destroy but failed to demolish before American forces arrived, radio reports reached First Army headquarters within minutes. The speed of information flow and decision-making that followed demonstrated how thoroughly American forces had mastered network-centric warfare decades before that term existed. Within an hour of the bridge's capture, divisions across the entire front were receiving orders to shift forces toward Remagen to exploit the breakthrough. Units that had been preparing for opposed river crossings elsewhere began moving toward the intact bridge. Artillery was repositioned to support the expanding bridgehead. Air support was redirected to protect the crossing site from German counterattacks. The coordination involved thousands of vehicles and tens of thousands of soldiers across hundreds of square miles, all coordinated through radio networks that allowed information to flow both up and down the chain of command at unprecedented speed. German forces, dependent on telephone lines that American aircraft had systematically destroyed, and radio systems that couldn't match American range or clarity, couldn't respond with comparable speed. When German commanders learned of the Remagen disaster, hours after it occurred rather than minutes, they attempted to coordinate counterattacks using communication systems that had been barely adequate in the early war years and were now completely overwhelmed. Orders were delayed or never arrived. Units lost contact with headquarters and each other. Counterattacks that might have had some chance of success if launched immediately arrived piecemeal over days, giving American forces time to establish an impregnable defense of the bridgehead. American radio coordination created that defense with a speed that seemed impossible to German observers. Tank platoons from different battalions, units that had never trained together, integrated seamlessly into the defensive perimeter. They coordinated fields of fire through radio communication, warning each other of threats and concentrating on German probes. Artillery observers in Sherman command tanks called in fire missions that arrived with devastating accuracy within minutes of identifying targets. The few German counterattacks that reached the bridgehead were destroyed in detail, broken apart by coordinated American responses, before they could mass sufficient force to achieve anything. The encirclement of the Ruhr pocket in April 1945 demonstrated the culmination of American communication superiority in an operational masterpiece that trapped over 300,000 German troops. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications. The two prongs of the advance, separated by over 100 miles at the start of the operation, maintained constant contact. They coordinated the timing of their movements to ensure they would link up at the optimal moment. They shared intelligence about German dispositions and adjusted their advances to avoid each other's artillery fire. The complexity of coordinating such an operation across that distance, across terrain that disrupted line-of-sight communication, while maintaining operational tempo that gave the enemy no chance to escape, would have been impossible without the radio systems American forces possessed. Inside the pocket, 325,000 German troops discovered that their communication systems had collapsed entirely. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and with each other. Field Marshal Walter Model, commanding Army Group B, sent increasingly desperate messages as his communication network disintegrated, but many never reached their destinations. His final messages before complete communication failure captured the German plight with stark clarity. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. The psychological dimension of communication superiority profoundly affected how soldiers experienced tank warfare, creating divergent realities for American and German crews that went far beyond tactical advantages. American tank crews fought with the knowledge that they were never truly alone. Even when physically isolated, when their tank had become separated from the formation by terrain or combat, they remained connected through radio waves. They could hear their comrades' voices. They could call for help and know it would arrive. They could share information about threats and coordinate responses. This psychological security, the knowledge that the crew's survival didn't depend solely on what they could see and hear directly, reduced stress and improved combat effectiveness. Crews that felt supported fought more aggressively and took calculated risks that isolated crews would avoid. German tank crews experienced the opposite, profound isolation. Unable to communicate except with the few vehicles equipped with transmitters, most German tankers fought individual battles within larger engagements. They couldn't call for help. They couldn't warn others of threats they'd spotted. They couldn't know if their comrades were still fighting or had been destroyed. This isolation created tremendous psychological stress that compounded the physical dangers of tank combat. German veterans' memoirs return repeatedly to this theme of isolation, of feeling cut off and alone even when surrounded by friendly forces. Otto Carius, one of Germany's most successful tank commanders who survived the war and wrote extensively about his experiences, described in his memoir, Tigers in the Mud, the challenges of limited communications, though interestingly, he focused more on tactical aspects than on the psychological dimension. Carius commanded Tiger tanks, which generally had better radio equipment than standard Panzers, but even his accounts reveal the constant struggle to maintain coordination and the frequent breakdowns in communication that left units operating blind. Reading between the lines of his tactical descriptions, the stress of operating with limited information and uncertain contact with friendly forces comes through clearly. For German crews in standard Panzers with receiver-only radios or no radios at all, the isolation was far more severe. They followed visual signals when they could see them and their own judgment when they couldn't, fighting their own private wars inside the larger battle. The strategic implications of American communication superiority extended beyond individual engagements to affect the entire tempo and character of Allied advances in 1944 and 45. American forces maintained operational momentum, partly through radio coordination that German forces couldn't match. The Third Army's famous race across France, often attributed solely to General George Patton's aggressive leadership, depended fundamentally on radio networks that maintained control across hundreds of miles. Patton could coordinate multiple divisions simultaneously because his headquarters could communicate with all of them. Forward units could report fuel shortages or enemy resistance, and receive new orders within minutes. Artillery and air support could be redirected to support whichever units were advancing most successfully. The flexibility and speed of American operations, the ability to exploit success and avoid becoming bogged down by local setbacks, all rested on the foundation of reliable long-range communication. German commanders consistently underestimated American capabilities because they couldn't conceive of the level of coordination Americans achieved routinely. When German intelligence reported American advances at speeds that seemed impossible, covering distances in hours that should have taken days, their reports were sometimes disbelieved or attributed to intelligence failures rather than accepted as accurate assessments of American capabilities. The idea that enemy forces could coordinate across such vast distances, could redirect entire divisions in response to developing situations, could maintain cohesion while advancing at speeds that should have fragmented their formations, all of this seemed to violate the fundamental constraints of warfare as German doctrine understood them. But American forces weren't violating those constraints. They had transcended them through technology that made distance and terrain far less significant obstacles to coordination. Heinz Guderian, serving as Inspector General of Armored Troops from 1943 onward, and struggling to rebuild German armored forces after catastrophic losses, recognized the communication problem but couldn't solve it. In memoranda and reports from late 1944, he acknowledged that American coordination negated German advantages in tank quality. He understood that superior vehicles fighting as isolated individuals would lose to inferior vehicles fighting as coordinated teams. He requested increased radio production, argued for universal deployment of transceivers, and attempted to prioritize communication equipment in the dwindling resources available to German industry. But by late 1944, Germany's industrial capacity was collapsing under strategic bombing, resource shortages, and the loss of occupied territories that had supplied raw materials. Radio production couldn't be increased significantly. Most new tanks continued rolling off production lines without adequate communication equipment, and Guderian's technical understanding of the problem couldn't overcome the fundamental constraints Germany faced. After Germany's surrender in May 1945, American technical intelligence teams fanned out across occupied Germany to evaluate German military equipment and understand the technological foundations of Wehrmacht capabilities. Their findings regarding German tank communications confirmed what combat experience had suggested, but documented it with devastating clarity. German tanks often possessed superior armor and armament. The Panther and Tiger tanks were formidable weapons platforms that outclassed the Sherman in direct comparison, but they suffered from catastrophically inferior communications that negated their technical advantages. U.S. Army Technical Intelligence Report number 176, filed in late 1945 after extensive examination of captured German equipment, concluded that German tank communications equipment was approximately 5 years behind American systems. The absence of frequency modulation, the limited radio distribution with most tanks carrying only receivers or no radios at all, and the poor electrical suppression that allowed engine noise to overwhelm transmissions, all of these factors created critical vulnerabilities that German forces had no way to address during the war. The report noted that German engineers clearly understood radio technology and had designed competent equipment for its era, but they had been working within constraints that American industry didn't face. The Funkgerät 5 was a reasonable amplitude modulation radio for the mid-1930s. It simply hadn't evolved at the same pace as American FM technology, and German production capacity couldn't provide adequate quantities even of that obsolescent equipment. Soviet evaluators, given access to captured German equipment as part of the post-war Allied intelligence sharing agreements, reached similar conclusions from a different perspective. The Red Army had struggled with communication poverty throughout the war and looked to both American and German systems for potential post-war development. Soviet technical teams examined German radios carefully, analyzed their design and manufacturing, and ultimately chose to copy American radio designs rather than German systems. This decision reflected practical assessment rather than political considerations. Soviet engineers recognized that frequency modulation represented the future of military communications, and that amplitude modulation, however well implemented, couldn't compete. The post-war Soviet tank communication systems that equipped the T-54 and later designs drew heavily on American concepts, though adapted to Soviet manufacturing capabilities and tactical doctrine. The Cold War would see both sides of the Iron Curtain equipping their tanks with sophisticated FM radios and recognizing universal deployment as essential, a lesson learned from the Second World War experience. The statistics of American achievement, compiled from production records and deployment data, reveal the magnitude of what the United States accomplished between 1941 and 1945. American radio production for the SCR 508, 528, and 538 family exceeded 50,000 units. Sherman tank production reached 49,324 vehicles. The radio deployment rate was 100%. Every single Sherman carried sophisticated communication equipment. The transmission power of 25 watts provided range and signal strength that overwhelmed interference. Crystal-controlled frequency stability of plus or minus 0.01% meant channels stayed precisely aligned. Operating range while moving reached 7 miles in typical conditions, extending to 10 to 15 miles when stationary. Compare this to German production and capabilities. Funkgerät 5 transceivers produced numbered approximately 6,000 units. Medium and heavy tank production reached approximately 12,000 vehicles. The full transceiver deployment rate was approximately 20%. Most German tanks lacked any ability to transmit. Transmission power of 10 watts was less than half American capability. Variable capacitor tuning with stability of plus or minus 1% meant constant retuning was necessary. Operating range while moving was half a mile to 1 mile, extending to only 2 to 3 miles when stationary. The disparity wasn't merely quantitative, but qualitative, representing different generations of technology and fundamentally different approaches to armored warfare. Communication effectiveness metrics tell the story even more starkly. Average time for an American fire mission, from identification of target to artillery rounds impacting, was 3 to 5 minutes. Average time for a German fire mission was 15 to 30 minutes, when it could be coordinated at all. The percentage of American tanks achieving full coordination was 100%. Every Sherman could communicate with every other Sherman. The percentage of German tanks with full communication capability was 20% at best, leaving 80% of German armor fighting partially or completely isolated. These weren't marginal differences. This was total information dominance, a revolution in military affairs occurring in real time as the war progressed, visible to anyone who looked but largely invisible to those who didn't understand what they were seeing. The radio superiority of Sherman tanks established principles that govern armored warfare to this day, principles that seemed revolutionary in the 1940s but have become so fundamental that modern military forces can barely conceive of operating without them. Modern main battle tanks, whether American Abrams, German Leopards, British Challengers, or Russian T-series vehicles, carry communication suites that trace their lineage directly to the SCR 508. The technology is digital rather than analog, encrypted rather than clear voice, integrated with computers and tactical networks rather than standalone radios. But the fundamental concept remains unchanged. Every tank must be able to communicate. Coordination requires reliable information sharing, and universal deployment is not a luxury but a necessity. The German Bundeswehr, rebuilt in the 1950s as West Germany joined NATO, prioritized communications based explicitly on World War II lessons. Every Leopard tank manufactured has carried comprehensive radio systems as standard equipment. A Bundeswehr training manual from the 1960s, examining the lessons of the previous war, stated with remarkable candor that the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. German military thinkers, analyzing their own defeat, recognized that they had been defeated not by better tanks, but by better connected tanks, and they ensured that future German armored forces would never again suffer from communication poverty. This lesson has been validated repeatedly in conflicts since World War II. The 1991 Gulf War saw coalition forces with superior communications destroying Iraqi forces, equipped with individually superior Soviet-designed tanks, but inferior radios and inadequate coordination. Iraqi armor, often technically capable and sometimes superior to the coalition vehicles they faced, fought blind against enemies who could coordinate perfectly. The results were reminiscent of Arakourt, kill ratios that defied technical specifications, achieved through information superiority rather than superior weapons platforms. The 2003 invasion of Iraq again demonstrated that network-centric warfare defeats platform-centric warfare. American forces, integrated through sophisticated communication networks, destroyed Iraqi armored forces that couldn't coordinate effectively. The lesson has been consistent across 8 decades. Connection equals survival. Isolation equals defeat. The technology has evolved from analog FM radios to digital networks, from voice communication to data links carrying video and computer information, but the principle remains constant. Modern military theorists speak of the network-centric warfare revolution as if it were a recent development, a product of computers and digital technology. But historians examining the Second World War recognize that the revolution actually began in 1942, when American Sherman tanks entered combat with universal radio deployment and frequency modulation technology. Every principle of modern network-centric warfare was demonstrated in embryonic form during World War II. The importance of information sharing, the value of distributed decision-making enabled by universal communication, the force multiplication achieved when every platform contributes to collective awareness, the degradation of enemy capabilities through superior coordination rather than superior firepower. These weren't abstract concepts in PowerPoint presentations. These were realities learned in the Tunisian desert, the Italian mountains, the French hedgerows and the German plains, purchased with the lives of soldiers fighting in steel boxes where information meant survival and isolation meant death. The story of American Sherman tank radio superiority represents a victory in the electromagnetic spectrum that proved more decisive than advantages in armor or firepower could ever have achieved. It's a story largely absent from popular histories of the war, overshadowed by narratives focused on battles and generals, on heroism and sacrifice, on the visible dimensions of combat rather than the invisible waves carrying voices through the chaos. But it's a story that reveals something fundamental about how wars are won and lost, about how technological advantages emerge from the interaction of innovation, industrial capacity, and doctrinal vision, about how assumptions about warfare can blind even sophisticated military establishments to revolutionary changes occurring before their eyes. German tank crews fought their war partially blind to this revolution, trained for visual signals and rigid hierarchies that had worked in the early war years, but became increasingly inadequate against an enemy that had transcended those limitations. They discovered too late that every Sherman tank was not just a fighting vehicle, but a node in history's first battlefield network, connected to every other American tank through electromagnetic waves that seemed as mysterious and powerful as any weapon. The SCR 508 radio, 181 pounds of electronic equipment manufactured in Chicago and installed in Detroit, transformed the M4 Sherman from an adequate medium tank into a component of a weapons system that included every other American tank on the battlefield. This transformation proved more decisive than any improvement in armor or firepower could have achieved, more valuable than the superior tanks the Germans produced in smaller numbers, more powerful than the numerical advantage the Soviets achieved through mass production. Every Sherman tank carried the tools of victory, not just in its 75mm gun or its sloped armor, both of which were adequate rather than exceptional, but in the 181 pounds of radio equipment that connected its crew to every other American tank crew fighting anywhere in the theater. This connection created a collective intelligence, a distributed awareness, a coordination capability that no individual German tank, regardless of its superiority in armor or firepower, could match. It created psychological security for American crews who knew they were never truly alone, and psychological isolation for German crews who fought individual battles within larger wars. It enabled operational tempo that German forces couldn't maintain and tactical flexibility that German doctrine couldn't envision. German forces discovered this reality through bitter experience repeated across 3 continents and 4 years of war. At Kasserine Pass, where veteran Afrika Korps tankers first witnessed American coordination they couldn't explain. In Italy's mountains, where terrain that should have negated radio advantages instead highlighted them. Across France's hedgerows, where American tanks and infantry learned to coordinate through simple phone boxes that bridged the gap between different radio nets. In Germany's final battles, where American forces exploited opportunities with a speed that German commanders couldn't match and couldn't understand. At every stage, German after-action reports noted unusual American capabilities, exceptional coordination, seemingly supernatural awareness of German movements. But these observations rarely translated into understanding of the technological foundation, and by the time German commanders recognized the full extent of American communication superiority, the war was effectively decided. The Wehrmacht never developed an effective counter, because they never fully understood the technological gap they faced, never recognized that frequency modulation represented a generational advance over amplitude modulation, never grasped that universal deployment was more important than providing superior equipment to command vehicles. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender, whether accurately quoted or apocryphal, captured a fundamental truth. "We knew how to build better tanks, but you knew how to make them work together." It was an admission that the war had been lost not through inferior weapons, but through inferior coordination, not through lack of courage or skill, but through failure to achieve the information dominance that American forces possessed as a matter of routine. America had built not just 49,324 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network, and that network proved more powerful than any collection of individual vehicles, however superior, could ever be. The revolution in military affairs that historians identify with modern network-centric warfare actually began in 1942, when the first Sherman tank with an SCR-508 radio entered combat somewhere in North Africa. From that moment, warfare changed forever in ways that wouldn't be fully understood for decades. The side with superior communications would defeat the side with superior weapons. The network would defeat the platform. The connected would overcome the isolated. These weren't theories or predictions. These were realities demonstrated daily on battlefields from Tunisia to Germany, learned by soldiers who might not have understood the broader implications, but who knew with absolute certainty that the radio in their tank was as important to their survival as the armor protecting them or the gun that let them fight back. This transformation occurred largely invisible to German forces, and even to many on the American side, who took their communication capabilities for granted. The Germans saw American tactical superiority, noted it in their reports, tried to counter it with improved tactics and better weapons, but didn't recognize its technological foundation until far too late. They attributed American coordination to training, to numerical superiority, to air dominance, to everything except the simple reality that American tanks could communicate reliably, while German tanks largely couldn't. By the time German commanders like Guderian understood that every Sherman tank possessed communication capabilities that most German tanks completely lacked, that this wasn't a matter of better training or discipline, but of fundamentally different technology, the war was effectively decided. Germany's industrial capacity was collapsing, resources were exhausted, and there was no possibility of bridging the gap that American forces had opened. The German military's failure to recognize and adapt to American communication superiority stands as one of World War II's great intelligence failures, a blind spot that persisted despite countless battlefield encounters demonstrating American coordination advantages. German leadership never prioritized solving their critical communication weakness because they never fully understood that it was a weakness. They continued building superior tanks designed to fight as isolated individuals, while American forces built adequate tanks designed to fight as coordinated teams, and the results spoke for themselves in kill ratios that defied technical specifications and operational successes that seemed impossible by traditional standards. In the end, the electromagnetic waves carried by SCR 508 radios proved more powerful than the armor-piercing rounds fired by German 88mm guns, more decisive than the thick armor of Panther and Tiger tanks, more valuable than the technical excellence of German engineering. The ability to coordinate, to share information instantly, to fight as a unified force rather than as individual vehicles, to maintain cohesion across distance and through terrain that blocked visual signals. This invisible advantage determined victory more surely than any visible superiority in armor or armament could have achieved. The Sherman tank's radio superiority changed warfare forever, establishing the principle that in modern combat, connection equals survival and isolation equals defeat. That information dominance outweighs platform superiority, that the most powerful weapon is often the one you cannot see. German troops discovered this reality on battlefields across North Africa, Italy, France, and Germany itself, learning too late that the Americans possessed not just numerical superiority or industrial advantage, but technological superiority in the dimension that mattered most: the ability to fight as one coordinated force rather than as thousands of isolated vehicles. That ability, purchased through innovation in frequency modulation technology, through industrial mobilization that achieved universal deployment, through doctrinal vision that recognized the importance of connecting every fighting vehicle, proved to be the decisive advantage of American armor in World War II, more important than any other single factor, in explaining why Sherman tanks, individually inferior to their German counterparts in armor and firepower, achieved consistent victory against supposedly superior opponents. The story of World War II is often told through battles and generals, through heroism and sacrifice, through the visible drama of combat. But beneath that visible drama ran invisible currents that shaped outcomes as surely as any tactical decision or strategic plan. The electromagnetic spectrum, that invisible realm of radio waves carrying voices through the chaos of battle, proved to be a decisive battlefield where American victory was so complete that the enemy barely understood they were fighting there. Every time a German tank commander struggled to hear orders through static, every time a German crew fought isolated because they had no radio at all, every time coordination broke down because command vehicles were destroyed, the invisible war was being lost. Every time an American tank crew maintained clear communication across miles of battlefield, every time coordination allowed them to concentrate force against isolated German vehicles, every time information shared through FM radios created tactical advantages, the invisible war was being won. And in the end, the invisible war mattered more than the visible one. The electromagnetic spectrum proved more decisive than armor or firepower, and the connected defeated the isolated as surely as day follows night. That lesson, learned at such terrible cost between 1942 and 1945, remains valid today and will likely remain valid for as long as humans fight wars. Connection is survival. Isolation is defeat. The network triumphs over the platform. Information dominance determines victory. These principles, first demonstrated by Sherman tanks, with their 181 pounds of radio equipment connecting them to every other American tank on the battlefield, govern modern warfare and will continue to govern it into the future. A legacy of World War II that extends far beyond the battlefields where it was first proven and continues to shape how nations prepare for and fight wars in the 21st century.